All right, so now let's do an example that is a Newsvendor example. So it has overage and underage costs. We have one opportunity to figure out how many to buy before the selling period. However, we don't have normal demand during that selling period. All right, so let's think about an RPI student organization, which is hosting a Super Bowl party, and they are selling decorations. And so they buy them for $8 each, and they sell them to people that attend their party for $18. That any decorations that are left over will just give to anyone that's organizing, so the salvage value is 0. For planning purposes, the officers are using an estimate for the average demand of 1.25 decorations, and they know this value is highly uncertain. And so because it's small and because it's uncertain, Poisson distribution is a good estimation of the demand. And so the question they have to answer is, how many decorations would you recommend that they buy for this party? All right, so we still do the same 3 steps. The first step is to characterize our probability distribution of the selling period. And so here it's Poisson demanded with a mean of 1.25. So what does that look like graphically? That is this red line, or sorry, the second line here, this gray line. That's what the demand distribution looks like. We could calculate that where theta is 1.25. We could plug in for Q of 0, and we'd get that the probability that the demand is exactly 0 is around 28.65%. The probability of demand is exactly 1 is 0.3581%, and so forth. And then the f of q, the big F of q, is the cumulative distribution function. In a discrete distribution, that's just the sum. If you want to know 4, it's the sum of 4, 3, 2, 1, 0, gives you the probability that demand is 4 or fewer. So that's the first step. So this would be a little more tedious than if you had normal demand because we don't have the z value, but you can calculate this using the equation for the probability distribution function. So that's step 1. Step 2 is we need the economic characteristics. And so we need the cost of underage and the cost of overage. And so as a reminder is they make $10 every time they sell a decoration. So they buy them for 8, they sell them for 18. So if I have 1 too few, if I'm under by 1, that costs me $10 in potential profit. But the overage cost is $8 because I invested $8. If I don't sell it, there's a 0 salvage value. So that's the cost of overage. And so now we need the critical value. If we plug that in, we get a value of 0.5556. And so now the last step is to determine Q star. So how do we determine Q star? We need to look at the cumulative distribution function. So that's the big F of Q column. And we need to set Q star such that the cumulative distribution function is at least 0.556. So if I set Q star of 0, nope, our cumulative distribution is only 0.28. If I set it at 1, though, all of a sudden it's above 0.556. So the correct answer is to set Q star at 1. By doing that, that maximizes our expected profit and minimizes expected cost.